Here we are. So we're working on interval problem number 1. We're looking at a man running 200 meters. I know that when I'm working with interval problems, my big goal is to be finding my velocity average. That's what we're being asked for. We're asked about the average speed for the whole race. So I'm solving the average. In notes, I gave you guys velocity average equals distance total divided by time total. Our goal is to find the total distance that was run and the total amount of time that it took. And then we can find the velocity average. I want to remind you guys, never just average velocities or anything like that. It doesn't work out right. So I'm going to take a look at my problem and I'm going to organize my data. I'm told right off the bat that he runs 200 meters. That's actually really handy. So the first thing that I actually get is my distance total. My distance total is 200 meters. Super useful. I'm told that my first 20 meters, okay, so I might break this up into 2 segments, first segment and second segment. D1 is my first segment, and that is equal to 20 meters. I go on and I'm told that he runs that first 20 meters at 2.5 meters per second, so my velocity 1 might be equal to 2.5 meters per second. Nice. I saw a lot of people organizing it in this way or trying to get to this sort of step. This is what you should be doing. And then our last part, D2, is 180 meters. And the velocity 2 for that is 12 meters per second. It looks like this person started kind of slow and then really put on a bunch of speed. Cool. So we don't know our total time. We do know our total distance. And we know information about each segment. So what I'm going to do here is use these to find T1 and T2. That was all kind of step 1. That's all organizing my data. A little bit of it is what I sometimes call step 0, which is just making sense of what's going on in the problem. A lot of times, if I get confused, I draw a picture. So that's step 1. Step 2, finding my formula. I'm going to be finding some times. Now I know that I've just got one key formula that I use all the time for everything right now. Velocity equals distance over time. And I want to solve for this time. Solving this for time is probably the most complicated because it's in the denominator. We can't just get it out of the denominator easily. So we'll go ahead and first get it out of the denominator, times t on both sides, so that I find that distance equals velocity times time. Now I can go ahead and divide both sides by v to find that time is equal to distance divided by velocity. So this is kind of key. Time is equal to distance divided by velocity. So that's going to be my step 2. I figured out my formula. I'm going to make sure my units make sense. In this case, meters and meters per second play along nicely, so step 3 goes pretty quick. Now I'm going to do this in 2 separate stages. I'm going to go through and I'm going to find T1, which is equal to D1 divided by V1. D1, 20 meters. V1, 2.5 meters per second. So calculating that out, I can take 20 divided by 2.5, and that's going to give me an answer of 8. My units in my velocity were seconds, so that's going to be T1 is equal to 8 seconds. I'll do the same thing for T2. T2 is equal to D2 divided by V2. and I'll just go up and I'll take a look. 180 meters and 12 meters per second. I'm just plugging these straight in. That's one of the things that makes it nice about putting everything neatly labeled like this, is that you don't have to try and remember which is which. You just go ahead, go reference what you've already labeled and plug it in. Big and organized helps a lot. And so if I crunch that through my calculator, 180 divided by 12, that's going to be 15 seconds. So I've got my T1 and my T2. To get my total time, it's just adding those together. So T total, let's get that up there where we can actually see it. T total is equal to T1 plus T2. So 15 plus 8 equals 23 seconds. So I know, I'm going to go to my next page here. I know that my T total is equal to 23 seconds. Referencing my problem again, my distance total was 200 meters. And of course, if the problem didn't just give it to us, we would be able to add 180 plus 20 to get 200 pretty easily. That's pretty straightforward. And remember that V average is equal to D total over T total. And so I just plug that in. 200 meters in 23 seconds. My velocity average, 200 divided by 23 equals 8.6956 ... I'm going to go ahead, I'm going to rearrange it, round to an appropriate number of sig figs. This one, we're given detail about 20 meters and 180. This one's a little bit tricky on the sig fig total because we haven't talked about addition much. I'm going to go ahead and tell you we're going to use our velocity information to limit that right now. So 2.5 and 12 meters, that's 2 sig figs. So I'm going to round this to 2 sig figs. If this one were set up like this on a test, I would probably not be too picky on the sig figs because I recognize that it's an odd bit of data.
Why do you have to do sig figs?
Because it's an important bit of practice to get used to this for future information. It also keeps in mind that we don't have limited precision on everything. Good question. So that's going to be 8.7 meters per second. Notice we can take those units from there, meters divided by second, meters per second. So that would be our answer there.